Okay, so now we're going to get to more complicated looking problems, but first what we're going to do is a little review of the chain rule. So in our warm-up today we used the chain rule, but let's just review it one more time. So if I know that f of x is equal to 3x squared plus 5x all to the fourth, I can use U substitution and the chain rule to help me find the derivative. So I'm going to let u be equal to 3x squared plus 5x. Therefore, y is equal to u to the fourth, because all of this becomes u, so u to the fourth. Then I take the derivative of each of those. 2 times 3 is 6, so I get 6x plus 5. And the derivative over here, 4 comes down in front, subtract 1 from the exponent. Then the chain rule says I just multiply the derivatives together. So I'm going to have 6x plus 5, and make sure you put that in parentheses. Very important that you remember the parentheses, because it's this whole quantity times this whole quantity times 4u to the third. Now I'm going to substitute back in for my u. My u is 3x squared plus 5x, and it's to the third power. Okay, so we usually don't like having the coefficient in the middle there, so I might want to rearrange that a little bit more and rewrite that with the 4 in front. Okay, so there's the derivative. So what if I wanted to go backwards? What if I was asked to integrate this? What would be the steps that would take me back to that? So what we're going to do next is we are going to actually take this answer and we are going to integrate it so that we end up back with this. Okay, so we need to, when we integrate something fancy like this, what we want to do is we first want to analyze it and recognize, do we have something that could be u and something that could be the derivative of u? So notice I've got 3x squared plus 5x. The derivative is 6x plus 5. Okay, so we're going to write that down. To integrate, we need to recognize the effect of the chain rule. Okay, so now we're going to go ahead and integrate this. So I'm going to do it on the next page so that I don't run out of room here, because I write really big. So I'm going to turn this over. So what we're going to do is we are going to say, okay, what if I started with that answer? 6x plus 5 times 3x squared plus 5x cubed, and I'm differentiating in respect to x. Okay, so this was my problem. Notice this is an indefinite integral. We're not going to evaluate it along an interval because I didn't give you any numbers on the summation notation. Okay, so we are going to use the chain rule in reverse, and we're going to use U substitution. So remember, there is no product rule, so we can't use the product rule. What we could do, if we were really desperate, we could write this out 3 times and multiply it out, probably using Pascal's triangle to help us, and then multiply it by this, and then multiply by 4, and then we could multiply it in parts. Integrate it in parts. But we're going to go ahead and learn something new, which is the U substitution. So what we need to recognize is that these parentheses here, one of them is the derivative of the other one. So if I look at 3x squared plus 5x, that's going to be my u. I'm going to call that my u, because the derivative of 3x squared plus 5x is 6x plus 5. 2 times 3 is 6, so I get 6x. So I recognize this right here as being the derivative of u. And I can write that as u prime, but for the sake of doing this integration, I'm actually going to write it as, du, du dx. So I'm differentiating u in respect to x, and I get this. This is my derivative of u. Another way of writing that is du dx. Okay, that's going to become important in just a second. All right, so therefore, I could rewrite this problem. This means therefore, those three little dots. Therefore, I could rewrite this. First of all, if I have a constant, I'm just going to keep it. So I'm going to put that on the outside because I'm just going to keep it. So keep my 4. dx plus 5, I'm going to rewrite that. That's u prime. I'm going to rewrite that as du dx. And now the parentheses here is going to be my u to the third power. And I still have my dx. Okay, so the reason why I wrote this instead of writing u prime, I wrote du dx is because du over dx times dx, the dx's cancel out. So I can now cancel out dx on the bottom, dx on the top. Those cancel out. So therefore, I'm left with 4 times the integral. I'm going to write the u first. U to the third du. Now, this is something that we know how to integrate. Okay? So you can think of that as in terms of, well, what if it was x? Okay, so this is the same thing as integrating x cubed dx. And we've done that. Okay, so we can go ahead and then integrate this. So this is just like integrating this part right here. It's just like integrating x cubed dx. Okay, we just have a different letter. That's all. All right, so we now have, let's copy this down again. We have 4 times the integral of u cubed du. So now we're going to take the antiderivative. So we are going to keep our 4, and then our antiderivative of u is we add 1 to the exponent, so it's going to be u to the 4th, and then we multiply by 1 over that exponent, so we're going to multiply by 1 over 4. Okay, so I added 1 to the exponent, and then I multiply by 1 over that exponent. And the du disappears at this point when I've taken the antiderivative, but since it's an indefinite integral, don't forget we have to do the plus c. Got to add our constant of integration. Now we're going to substitute back in for u. Okay, so if I substitute back, 4 times 1/4 is just 1. And then my u, what was my u? My u was 3x squared plus 5x. And that is to the 4th power plus the constant of integration. Okay, and I don't actually need the 1. Whoops, where am I? Sorry about that. Got off the bottom. I don't need to write the 1. So it would just be 3x squared plus 5x to the power of 4 plus c. Okay, so remember, we were going backwards from the chain rule that we used before. So let's see how we did. If we go back, did I actually do it right? 3x squared plus 5x to the power of 4. Notice there was nothing else added over here, so our constant of integration would be 0. And there it is. So we got it correct. Okay, so that was kind of easy because we knew where we came from. So let's do an example where we don't know where it came from. So let's do our next example. We're going to integrate square root of x cubed plus 2x times 3x squared plus 2 dx. Okay, differentiate. We're going to integrate in respect to x. Okay, so we need to look at what we've got here and recognize, is one of these the derivative of the other? So the thing you're looking for is look for the higher exponents. Okay, so look for bigger exponents. Bigger exponents. Who has the bigger exponents? That's going to be your u. To find u. Okay, my bigger exponents are right here. So this is going to be my u. So I'm going to go ahead and write it out on the side here. My u is going to be x cubed plus 2x. That's going to be my u. And then what's the derivative of u? We write that as du dx. That would be 3x squared plus 2. And lo and behold, there it is. So this is going to be my u, and this is going to be my derivative of u, my du dx. That's my derivative of u right there. So now I can rewrite my integral in terms of u and du dx. So I'm going to rewrite it, substitute in. So this would be the square root of u, because notice my u is just the x cubed plus 2x. So it's going to be the square root of u. This part is du dx times the original dx. Okay, and then notice what I have here. The dx's are going to cancel out. Dx on the top, dx on the bottom. So I'm left with the integral of the square root of u du. Now I can integrate it. Okay, so one thing, how do I integrate the square root of u? I need to rewrite that with an exponent. So I'm going to rewrite that as u to the 1/2. Still have my du, integrating in respect to u. Okay, so now I'm going to do my antiderivative. I'm going to add 1 to 1/2. U to the 1/2 plus 1 is 3/2. And then I'm going to multiply by 1 over 3/2. So just a little aside here. 1 over 3/2 is equal to 1 divided by 3/2, which is equal to 1 times 2/3. Okay, so just a little aside. When I bring that down, it's just the reciprocal. So that's going to be 2/3. So I've done the antiderivative, and I need my constant of integration. Now I'm going to substitute back in my value for u. So I have 2/3, and then my u is x cubed plus 2x. And then I have my 3/2 plus my constant of integration. And there it is. And we could check it by taking the derivative of that. If I brought down 3/2 times 2/3, that would cancel out. That would just be 1. And then I'd have my x cubed plus 2x raised to the 3/2 minus 1 would be 1/2. And then I'd have to use the chain rule. I'd have to multiply by the derivative of this, which is 3x squared plus 2. So it matches the original problem. Okay? So that is using the chain rule. I'm going to do one more example. Now that I think about it. Okay, so I'm going to integrate 3x squared plus 2 over x cubed plus 2x squared dx. Okay, so again, we're going to look for the higher exponent values. Those are right here, so that's going to be my u. So my u is going to be equal to x cubed plus 2x. So my du dx, my derivative of u, is going to be, bring down my 3, that would be 3x squared plus 2. So I'm just taking the derivative of this. Now I'm going to see, is it up here? Do I have the derivative? Yes, I do. So this right here is my du dx, and this right here is my u. So now I can go ahead and rewrite my integral as du dx over u squared times dx. When I multiply du dx times dx, the dx's cancel out. So I'm left with du over u squared. Okay, that looks kind of weird. So let's move the u back to the top. When I move the u to the top, it becomes a negative exponent. So I have u to the negative 2 du. Now I'm ready to integrate it. So the antiderivative, I'm going to add 1 to the exponent. So I get u to the negative 2 plus 1 is negative 1. Multiply by 1 over negative 1. 1 over negative 1 is just negative 1. And plus my constant of integration. Now I'm going to substitute back in for my u. So negative 1 times my u is x cubed plus 2x. And that's to the negative 1 plus my constant of integration. And let's rewrite that without a negative exponent. So the negative 1 is going to stay in my numerator. And on the bottom, I'm going to have x cubed plus 2x, and keep my constant of integration. And that's it. Okay, and then I could check it. I could go backwards and figure out what the derivative of that would be using the chain rule. And since these are notes, I'm going to just tell you I'm right. Okay, there it is. So I'm going to stop the notes there. Notice we haven't done anything with natural logs or cosine or sine. We're going to get to that in the next set of notes. I'm going to stop it at this point right now. Thank you. Goodbye.